Hey everyone, and welcome back to the channel. Imagine this. You've just spent weeks, maybe even months, perfectly setting up a server for your new application. Everything's running smoothly, but then disaster strikes. The server crashes, and all that hard work vanishes. Or your app becomes a huge hit overnight, and you suddenly need to set up 10 more identical servers. The thought of manually repeating every single step is a nightmare, right? What if I told you there's a way to build, change, and manage your infrastructure safely, consistently, and on repeat, just by writing code? This is the magic of infrastructure as code, or IAC. Stick around, because by the end of this video, you'll understand exactly what it is and why it's a total game changer for anyone working with servers. So, what exactly is infrastructure as code? At its core, it's the practice of managing and provisioning your entire IT infrastructure, servers, networks, databases, you name it, through machine-readable definition files, rather than physical hardware configuration or interactive tools. Think of it like a recipe for your perfect server setup. Instead of manually clicking through menus in a cloud console or typing commands one by one into a terminal, you write down all the steps and specifications in a code file. This file becomes the single source of truth for your entire environment. Need a new server with specific software installed? You define it in the code. Need to update a firewall rule? You change a line in the code. This simple shift in mindset from manual actions to coded definitions unlocks a world of automation, consistency, and scalability that was previously impossible. It treats your infrastructure just like you treat your application code. Now, you might be thinking, this sounds great, but how does it actually work? Well, the process generally involves three key components. First, you have the definition files. These are the text files where you write your infrastructure code using a specific language or syntax, depending on the tool you're using. We'll talk about tools like Terraform, Ansible, and CloudFormation in a bit. Second, you have the IAC tool itself. This is the engine that reads your definition files. It understands what UV described like. I need a virtual machine of this size with this operating system, and then it communicates with the underlying platform, like Azure or Google Cloud, to make it happen. The tool is smart enough to figure out the current state of your infrastructure and what changes are needed to match your code. This is often called the desired state. Finally, you have the infrastructure platform, which is the cloud provider or virtualization environment where your resources are actually created. The IAC tool acts as the intelligent middleman, translating your code into real, running servers and services. One of the biggest wins with IAC is reproducibility. Because your entire setup is defined in code, you can recreate it perfectly, anytime, anywhere. Imagine you have a development environment, a staging environment, and a production environment. With IAC, you can ensure all three are configured identically just by running the same code. This dramatically reduces the "it works on my machine" problem, where differences between environments cause unexpected bugs. If a server goes down, you don't have to troubleshoot and manually rebuild it. You simply run your IAC script, and a brand new, perfectly configured replacement is provisioned automatically in minutes. This ability to tear down and rebuild environments on demand is incredibly powerful. It means developers can spin up their own isolated, production-like environments for testing, and then tear them down when they're done, saving on costs and ensuring clean, repeatable tests every single time. It brings a level of predictability and reliability that manual processes just can't match. Another huge benefit is version control. Since your infrastructure is just code, you can store it in a version control system like Git right alongside your application code. This is a massive advantage. Every single change to your infrastructure is now tracked. Who changed the database size? When was that firewall port opened? With Git history, you have a complete audit trail. You can see the entire history of your infrastructure, revert to a previous working version if a change causes problems, and collaborate with your team using familiar workflows like pull requests. This allows for peer review of infrastructure changes. Before a change goes live, another engineer can review the code, catch potential errors, and suggest improvements. This collaborative approach makes your infrastructure more robust and less prone to human error. It moves server management from a mysterious black box task performed by one person to a transparent, team-owned process. Let's talk about scalability, because this is where IAC truly shines. Your startup's app just got featured on a major news site and your traffic has exploded. You need to go from 2 web servers to 20 right now. With manual setup, you'd be in for a long, stressful night. With IAC, it can be as simple as changing a single number in your code file from count equals 2 feet to count equals 20, and running the script. The IAC tool will then automatically provision the 18 new servers, configure them, and add them to your load balancer. It's that simple. This is called horizontal scaling, and EOC makes it almost effortless. The same principle applies to creating new services or entire new regions. Want to expand your service to Europe? You can reuse your existing EAC modules, make a few region-specific tweaks, and deploy a complete copy of your infrastructure on the other side of the world in a fraction of the time it would take manually. This agility is a huge competitive advantage in today's fast-paced digital world. Of course, to get started with IAC, you need the right tools. The landscape is rich with options, but a few big names dominate. First, there's Terraform by HashiCorp. Terraform is cloud agnostic, meaning you can use it to manage infrastructure across multiple cloud providers like AWS, Azure, and Google Cloud with the same workflow. It uses its own declarative language called HCL, which is very readable. You declare the desired state of your infrastructure, and Terraform figures out how to get there. Next up is Ansible. While it can do provisioning, Ansible's real strength is in configuration management. It's great for tasks like installing software, applying patches, and managing services on existing servers. It uses YAML for its playbooks and is agentless, meaning it communicates over standard protocols like SSH. Then you have cloud-specific tools like AWS CloudFormation or Azure Resource Manager. These are deeply integrated with their respective clouds, giving you access to the latest services immediately. The downside is they lock you into that specific provider. Choosing the right tool often depends on your specific needs. Do you need more configuration management or provisioning? Many teams even use a combination, like Terraform for provisioning the servers and Ansible for configuring what's on them. So, how do you put this all into practice? Let's walk through a simplified example using Terraform. First, you'd install Terraform and set up your cloud provider credentials. Then, you create a file, maybe named main.tf. Inside this file, you'd write your code. You'd start by defining the provider, like AWS. Then you'd define a resource. For example, you could write a resource block for an AWS_instance, which represents a virtual server. In this block, you'd specify the Amazon Machine Image or ME2 used, the instance type like T2.micro, and maybe some tags for organization. Once your file is ready, you run a few simple commands in your terminal. First, Terraform init to initialize the project and download the necessary provider plugins. Then, Terraform plan.it. This is a crucial step. Terraform shows you exactly what it's going to do, what it will create, change, or destroy without actually doing it. It's your chance to review the changes. If everything looks good, you run Terraform apply. Terraform will then connect to AWS and build the server exactly as you defined it. And just like that, you've created infrastructure with code.